Hey everybody, this is Larry. This is day 29th of the May Leetcode Challenge. Let me know what you think. Hit the like button, hit the subscribe button, and let's get started. Course schedule. There's a total of number of courses that you have to take, labeled from 0 to number of courses minus 1. Some courses may be prerequisite. For example, take course 0 and you first have to take course 1, which is expressed as a pair 0, 1. Given the total number of courses and a list of prerequisite pairs, is it possible for you to finish all courses? Okay, so this is a very straightforward question about topological sorting. And basically, you can define it in a couple of ways, but the way that I tend to do about it is I actually use the breadth first search version. But you can also do it with the depth first search version, and you can phrase it kind of in terms of keep on asking questions, if you will. That's the way that I think about it. And what I mean by that is that given the number of courses and little prerequisite pairs, that means that for me, is asking myself, am I able to take course 1? And then from that, you look at the prerequisites, right? Like if to take course 1, you have to take course 0. Then you say, okay, well, in order to take course 1, I have to take course 0. So then you recursively ask yourself that question of, well, can I take course 0? And then so forth. The only case that this will not be good is if there's a cycle. So you can actually, in this case, it is you don't need. So in this case, it's not necessary as a to do the full topological sort, because this is a simpler version of the topological sort. Though uh, it is good to know topological sort in general, because that will come up a lot in both interviews and competitive programming. But in this case, you can solve it with cycle finding, because another way to put it is, well, if you get into an infinite loop, then there's no way to take all your classes. And there are a couple of ways you can solve it. For me, I'm just going to do the depth first search version, which is what I talked about, because it is easier for me to express itself as it's just easy linguistically, right? Because as I said, in order to take, you just keep on asking yourself, can I take this class? Well, I could take this class if I could take all of the classes that are its prerequisite. And then you just do a little bit of keeping track of which courses that you are already trying to take. And if you've already seen the same one, then you know that is not true, and then you just return. So that's what I'm going to do. And I am going to, in Python anyway, going to take advantage of some local globals, if you want to call it that. So let's see. So that's it. To scene is you go to set. So now now we have a depth first search, or just a recursion really. I'm going to name it can take class, or can take course, and then just take a number of course number, right? And then now, if what are the base cases, right? Well, I think there is no quote unquote no base case, in the sense that the base case is the absence of an untrue case, which means that, as we said, we can take this course if we can take all the courses below. So you could put the if statement somewhere, but for now I'm just going to go on. Oh, I think so. Now I took a little bit longer, but if I look at the prerequisite as a list of edges, not adjacency matrix. So now actually let's just pass this for now. But let's process that into an adjacency list. I find that a little bit easier, though. You may use whatever it is that you're more comfortable with. Yeah, so adjacency list is equal to I in Python I use the default dictionary class with a list. So then we can just do for which one is gone? I just want to see which order it is, just to make sure, because sometimes people who write these poems do it in a weird way. So I just want to make sure. So 1 has a prerequisite of 0. Okay. So now let's just go. I was going to call it UV, but then people make fun of me for saying that that's not readable, though it is a graph theory thing. So I didn't make up U and V, but let's just say for each, I want to say class, but I think that's a keyword, right? So for each course, and then the prereq in prereq. So in that, we just do the adjacency list, or we could maybe even rename this to be something more precise, but just call it prereqs. So prereqs of course append prereq, right? So now our prereqs will contain a list of, for each course, a list of its prerequisite courses. Okay, so now we can make this a little bit easier. We can do for prereq in prereqs of course if not can take course a prereq, then return false, kind of, right? And then if we can do all of them, then it's return true. So this is not complete, of course, but that's kind of the skeleton of what we want to write. Right now we have to think a little bit harder about how to do this, right? We have this scene array, so, and we have our set, and we have to take advantage of it, because if we just do this, we'll definitely get an infinite loop. So in order to avoid seeing the same thing twice, let's just say if the prereq is already in scene, let me think through it a little bit first. So, okay. So let's say if this course, or sorry, if this prereq is already in scene, what does that mean, right? That means that, yeah, that means it's no good, because I was thinking in different cases where you have undirected graphs, but this is a directed graph. That means that if you've already seen this, then it's already false. So let's say with prereq, it's in scene, or not tick, then return false. I think that's all you need, except for that you have to set scene to true. So now, when we process a course, let's just set scene is equal to course. So that means we already processed it, or processing it. I think that should be enough. And then now we just have to look at each course. To make sure. Because in this case, so the scenario that I'm thinking of is that you, instead of having a sort of a tree, kind of, because there's cycles and stuff like that, but instead of just like graphs, you have different components that are separate totally from each other, and you have to handle them independently, but then together giving you, combining them later to take one result. And I think for that, you can actually just do it for each one, as if they're not seen. Okay. So basically, for each course in range from number of courses, let me double check that is 0 index. Okay, it's 0 index. Then if prereq not with course not in scene, then we want to process it. If we already seen it, that means that we have already checked it in the past. So that's why we do it this way. If it is not in scene and not can take course, then we return false. Otherwise, we return true if that's the case for all of them. And we can trust that when we do this, this will modify the scene. Okay, now let's run the code and add some more examples. And as I always usually point out, because the results are Boolean or binary, sometimes I'm a little bit more careful, because even if you get these right, and in this case I was wrong, but even if you get this right, it's like half-half, right? It's not quite the same. It's not quite half-half depending, but it does not give me that much confidence even if I got them all right, which in this case I did not. But let's see why that this is the case. Oh, okay. So the reason why this is not right is because of this thing. So I have to think about another way of doing it. Because essentially what happened was that I processed the 0 first. So then, of course, it sets the scene, but 1 depends on 0. So yeah, so that's not great. there were a couple. So I was. So we have to think about how to handle it. There are a couple of ways we can handle this, but I guess in a weird way, having if we had done this with topological sort, then this would actually be really straightforward um, to convert, because then you just do it from the top of the topological sort trees and stuff like this. But but hmm, I think I think so. For me, one thing that I also want to point out is that for stuff like this, sometimes is that you get stuck into a way of thinking because you think you recognize a problem, but then it might not be that complicated. It might not be need to be that tricky, right? And I think this may be one of those cases in that in that I have to kind of yeah can figure out how to do it correctly with respect to this. And I think the reason why this is wrong is because we're going from 0 to n minus 1 like this, but that is not the topological sorted way of doing it. So then you end up with issues like this where you're doing it in the wrong order. Uh, so what is the right way to think about it? Hmm. Without well, the right way to think about it might be actually is to backtrack a little bit and be like, okay, actually, we just need to do the topological sort. Uh, but yeah, okay. I was trying to figure out ways to hack around it, and there are, I think, ways you can hack around it, but then it would change the complexity to n square or something like that, or you can maybe like cache some results or have some intermediate um, variables, but I think that makes it a little bit more confusing to understand. Um, hmm. Yeah, let's just do it with topological sort, because I suppose that would because that's essentially what this thing we have to do anyway to fix this part. So yeah, and there are a couple of ways to do topological sort. All right, we'll keep the prereq list. So there are a couple of ways to do topological sort. There's the breadth first search version and depth first search version, and you feel free to do some research on that. But the way that I will do it in this case would just be depth first search. Oh, sorry, breadth first search. So I gave you a little bit hint of how to do it with breadth first search. So now I'm going to do it with depth first search. And sorry, keep on saying it with breadth first search. And the way that I would think about a breadth first search version is just writing basically in degrees. So each node, you just keep track of how many number of prereqs, and also keep track of um, number of cases where it is the prereq of another class. Yeah. Okay. So number of prereqs is equal to. So I guess in this case, this is just an implicit thing under this graph. So let's just say num. Um, so what I'm thinking of writing is just out degree, but or in degree, but then I'm just trying to figure out a better context wherever of it. Number of is prerequisite. So number of times it is the prerequisite, and that will start with 0 times number of courses. Okay, and then now we can just write number of. This is a mouthful. Of course is no prereq, just increment by 1. And then now we set up the breadth first search. Let's start with a queue or a deck. And now let's go through all the courses in number of courses, range of number of courses. Can't spell today. And then now if Let me think. So um, if a if a class have no prereqs, that means then we can take it as soon as possible, right? So let's append that class into the queue. I can't spell course today. It's one of those things where you type something like 10 times and then it confuses you, at least for me anyway. Okay, now we can do, let's have a scene. Yeah, let's have a, we already have the scene set. So now we just do while length of queue is greater than 0. So the course that we're taking now is the first course, and then we do pop left. And what happens when you take this course? Well, when you take this course, then now you're able to take other courses that have this as prereq. So actually, I think I set this up a little bit incorrect, which is my fault. So actually, I think I need the opposite of this. And, number of prereqs. So now, why I like about topological sort is you can say this with English and it will make sense. Which is what I'm saying is, okay, if this course, the number of prereqs of this course is 0, that means if there's no prereqs, we can take this course now. And then now, let's say we took this course. Well, what happens when you take this course? Well, now other courses that have this course as a prereq can take, you can now take courses that, like if you take Physics 101, now it unlocks Physics 102 for you, right? So that's essentially what we're going to try to do. So now for, yeah, so this is actually not prereq, so maybe that's the name of it. Yeah, for unlock course, say, in, let's just rename this as unlocks. It's a little bit of a long video, but I think there is some value in being able to be wrong and changing how you think about things and start over is kind of critical, because sometimes, especially in competitive programming, if you get stuck in one way and you're really stuck to it and you're super convinced you're right, but you're only a little off, that doesn't mean that you're right. Right? And you have to be able to kind of do what it takes to get the right answer, the AC, right? The accepted code. Okay, so for now, for each unlocked course, we can do number of prereqs of the unlocked course. Okay, now the -1 because now that course has one fewer prereq, and then if this number of prereqs of this unlocked course is equal to 0, that means this course is fully unlocked, and then now we could append unlocked course. And in theory, for each course, this can only happen once, so we don't have to add any scene or anything. So actually, I don't need this. And for every course that we unlock, we want to keep a count. So let's just keep a count. So 0. Here, we just increment by 1. And then now at the very end, we can just return where the count is equal to the number of courses, which is saying if the number of courses that we end up taking at the end is equal to the total number of courses, then we're good. So that's one code again. True, false. And again, as I said earlier, with these Boolean things, it's always, I don't know, I'm not necessarily convinced. So these two examples are pretty good. Those are the examples that you imagined would be, would be really representative of the test cases possibly. but let's just add another one. But cool. Yeah, so let's submit this. I think I'm confident enough about this. Maybe there's an edge case. Cool. So I did get this accepted on the first try, even though that took a little bit of a long way about it. But yeah, I mean, I think, but topological sort comes up all the time. Definitely be prepared to do it. There are also two ways of doing it with the depth first search and the breadth first search. I did it with breadth first search because I feel like I don't see it enough in people's writing. But you can do it with depth first search. That is also as well. So I just want to show you that it can be done with breadth first search. Yeah, and in terms of complexity, well, each node here will only get processed once for what we talked about, because this thing can only be true for each node once, and that's all we're putting on a queue. For each edge and each node, the work that it does, well, it works for each edge on the node. And this, if you could do some math, but you could show that the sum of all these things, the number of total numbers of edges and unlocks is just equal to prerequisites, because, well, for each edge and prerequisite, we create one edge, right? So this is O of E, where E is the number of edges in total, right? Not per node. So in that case, this running time is O of V plus E, which is the lower bound, because you cannot do better than reading all the data at least once. And the space in this case is also O of V plus E, because we converted to an adjacency list. And also we have this, which is O of N. But so it's O of V plus E is the running time. Yeah, overall an interesting problem. Definitely a problem that I get a lot, but I do like doing it with breadth first search, because as I said, you can ask yourself these questions in English. And for me, you may have, when you watch me solve this, you might notice that I take an extra second. It doesn't come natural to me, in the sense that I don't have patterns memorized for these things. What I asked myself was, well, how would I prove to myself that is correct in an understandable way? And I did that by asking myself, okay, what are the questions that we're asking at each step of time? And at each step of time, I'm asking, okay, let's see what classes we can take in the beginning. Well, the classes we can take in the beginning are the classes that have no prerequisites. And then now, let's just say we took a course, and then for each class that we have this class as a prerequisite, well, they have one field prerequisites. And then now, if those classes now have 0 prerequisites, we can take this class and we add it to the queue. And then at the very end, we're like, okay, how many classes did we end up taking? If we took all of them, then we can take all the classes, right? Which is actually literally what you have to say. But yeah, overall, good problem, fun problem, good practice, and I will see y'all tomorrow. Let me know what you think. Let me know how you did it with the breadth first search, with depth first search, or maybe another funnier algorithm. Would love to hear from you, and I will see y'all. Bye. Bye-bye.